Hello friends, in this AV we are going to take up the numericals of chapter 4 of class 10 physics, that is refraction of light at plane surfaces. In this AV we are going to do the third exercise of chapter 4, that is exercise 4C, and here the numericals would be based on the real and apparent depth, which comes under the portion simple application of refraction of light. In this section also we just have three numericals, so let's try to solve them one by one. The first question says a water pond appears to be 2.7 meter deep. If the refractive index of water is 4/3, find the actual depth of the pond. So here they have given us the apparent depth of the pond, that is 2.7 meter, and they have given us the refractive index of water. We just have to find out the actual depth. So we would be using the formula real depth is equal to apparent depth multiplied by the refractive index. So here we have written the given things, that is apparent depth is given in the question as 2.7 meter. The refractive index of water is 4/3. Now we know the formula that we are going to use here is real depth is equal to apparent depth multiplied by the refractive index of water. So real depth will be equal to apparent depth value is 2.7 multiplied by the refractive index of water, that is 4/3. So you can cancel it out, you will get 0.9 here. 0.9 multiplied by 4 is 3.6 meter. That is the answer. Now the second part of the second question says a coin is placed at the bottom of a beaker containing water. So refractive index of water is 4/3. This is the value of mu W to a depth of 12 centimeter. Now this is the real depth at which the coin is placed. By what height the coin appears to be raised when seen from vertically above? That means we have to find out the shift or the apparent depth. So here we have written the given things. Refractive index of water is 4/3. Real depth of the coin is 12 centimeter. So we know that shift is equal to real depth multiplied by 1 minus 1 by refractive index. So refractive index is 4/3. So when we write it here in the denominator, it reciprocates and we can write it as 3/4. So real depth is 12 multiplied by 1 minus 3/4. So first we need to solve this part. When you take LCM, you will have here 4 minus 3 upon 4. So 4 minus 3 is 1 upon 4 is, here we are writing it. So 1/4. When you solve this, you get 1/4. So 12 multiplied by 1/4 is nothing but 3 centimeter. Now we take a look at the third question or the last question, which says a postage stamp kept below a rectangular glass slab of refractive index 1.5 when viewed from vertically above it appears to be raised by 7 millimeter. We have to calculate the thickness of the glass slab. Now here first of all they have given the refractive index of the glass slab, that is 1.5. Then they have given the shift in image, that is 7 millimeter. So this entity we need to convert it into centimeter. So we will just divide it by 10. So it will be 0.7 centimeter. Now we have to find the thickness of the glass slab, which is equal to the real depth. So for this, here we have written the given things. The refractive index of glass slab is mu G, that is 1.5. It's given in the question. Shift in the image is 7 millimeter, which is equal to 0.7 centimeter. We just divide it by 10. When you have to convert millimeter to centimeter, you divide by 10. Now the thickness of the glass, which is the real depth, is what we have to find out. So we know, we write the formula that shift is equal to real depth multiplied by 1 minus 1 by refractive index. So shift is given as 0.7 centimeter is equal to real depth is what we need to calculate, multiplied by 1 minus 1 by refractive index. The value of refractive index is 1.5. So we need to calculate R. So we keep R on one side and we solve this and cross multiply. So here when you take LCM, this part becomes 1.5. So 1.5 minus 1 will be 0.5. This 0.5 will go in the denominator here. This is what we have written, and this denominator 1.5 will be cross multiplied with 0.7. So R is equal to, that is the real depth, is equal to 0.7 multiplied by 1.5 divided by 0.5. So this is a very simple calculation. When you calculate it, you will be able to get the answer as 2.1 centimeter. So that's all in this AV. Happy learning. God bless.